Hello again everyone, welcome back to ptet.chemistry channel. My name is Dr. Ant. In this tutorial video, I'll go through this work 3. This is for the Combined Science 5129. So Combined Science is 3 sciences combined into one, and as such the content are a bit more diluted, but it's suitable for any Combined Science curriculum for 14 to 16 years old students all around the world. In this work 3 for this acid, bases and salt topic, this first question is showing you a reaction between potassium metal. So potassium is in group 1 of the periodic table, and you will know that this has a 2881 electronic configuration, where that is the first shell, that is the second shell, that occupy the third shell, but the fourth shell is not filled completely. Instead, it has just 1 electron in the outermost shell, hence it is what you call a group 1 metal. Chlorine, on the other hand, is a group 7 nonmetal. So group 7 nonmetal there, 287. So group 7 has got 7 electrons in the outermost shell, and then your first and your second shell is completely filled as they are part of the inner shell. So here, potassium reacts with chlorine, and what you get is a salt. This salt is called potassium chloride. So what we get also is we see flames. Flames basically meaning that, you know, there is a burning. There's burning fire essentially. Okay. So write the word equations. So the first question, write the word equations. They are not asking for the chemical equations. If you write a chemical equation, you must balance it, of course. And we know that chlorine exists as a diatomic molecule. Because of the 287 electronic configurations, it has got incompletely filled outer shell, so they share 1 electrons with the neighboring nonmetal of itself, which is another chlorine atom. And because you use 1 out of 7 outer shell electron for bonding, you have 7 originally of these crosses. You share 1 dot from the neighboring chlorine, and these 7 dots originally, because of 7 electrons in the outer shell of chlorine, also share 1 cross from the other chlorine, and as such what you get there is a single covalent bond. A single or 1 covalent bond is a result of 2 electrons being shared. This is what you call diatomic molecule, because you have two atoms bonded together by covalent bond there. In this word equation, what we have really is potassium. The spelling, of course, is in the question. The spelling is also in the periodic table. Chlorine exists as this Cl2 diatomic molecule. The salt that you get, according to the question, the salt that you get is going to be called potassium chloride. Now explain which observation in the figure. So you have to explain, you gotta explain why it's exothermic. In the previous topic, as we cover in the Combined Science 5129 curriculum or any other Combined Science curriculum, you will have learned that exothermic reaction means it releases heat energy to the surroundings, and therefore the surroundings see an increase in temperature. So very clearly we see flames here. So we see, or we observe, the reactions produces flame, the reaction gives out flames, or you can see the flames. So that was in the question. So that means exothermic reactions, because exothermic reactions, as defined in the syllabus, it releases heat energy. It releases heat energy to the surroundings, and that is why the surroundings will increase in temperature, the surroundings get hotter. That is part of the definition of exothermic reaction. So the surroundings increase in temperature, the surroundings get hotter. Part B, so this question is saying that potassium chloride, which is a salt by the way, and potassium coming from a group 1 metal. So potassium will have lost 1 electrons. That's why you now have a +1 charge. And what you have from the chlorine is that there is a group 7 nonmetal, and they would have gained 1 electrons to give you a Cl-, a -1 charge ion there. 1 and 1 is what you call the valency, or the combining power of the ions based on the value. The value of the charges give you the valency or the combining power. You do cross multiply and making sure that these are in the simplest whole number ratio. That means you have 1 of K plus and one of these Cl minus, and therefore when you combine them together, the formula, you don't write the charges anymore because you just look at how many you have, one potassium, one chlorine, that is potassium chloride, correct formula. This question is asking you to name type of reaction between an acid and an alkali. This is straight from the energy changes topic. Energy changes topic is called energetics. This is called neutralization reaction, because between an acid, what you have in an acid is your H plus ion. In an alkali, you have OH minus ion. Together, they will react together and give you liquid water. So this is reaction between acid, where the pH is lesser than 7, and hydroxide ion, OH minus, an alkali or a base, the pH is above 7. The next one, they want you to name the acid and name the alkali. They give you potassium chloride. You want to get a chloride salt, so the acid you use will be called hydrochloric acid. But this next one is a bit more tricky because this is the alkali. Alkali contains your hydroxide ions. OH minus is the correct formula. The name, which sometimes they ask you to name the ion, is called hydroxide ion. We have our potassium in the salt, so this has got to be potassium hydroxide as your alkali there. Part 3. Suggest how would the solution of potassium chloride be tested. So you have to do some tests to make sure it does not, read the question, does not contain excess acid or alkali. So if it does not contain excess acid of course give you your H plus, your pH is lesser than 7. On the other hand, your alkali, your OH minus, which is your hydroxide, your pH is greater or above than 7. If this solution does not contain excess acid or alkali, then its pH is pH 7. Use universal indicator as stated in your syllabus. If you check back on the lecture tutorials or your notes, use universal indicator. At pH 7, it shows green color. So there is green color for neutral pH, which is pH 7 with a universal indicator. Of course, you could also use a pH meter. If you use a pH meter, this is a digital scale. So digital reading will read or should read pH 7 because there will be the neutral pH. When you have neutral pH, you don't have excess acid or alkali there. Last being this question, describe briefly how you can get dry and you want to get crystals and you get it from the solution. So that means you already did the reaction between acid and base and you already know that you have exact amount of potassium hydroxide, exact amount of hydrochloric acid that combine together to give you the potassium chloride and water. This thing dissolve in water to give you the solution without excess acid or alkali. Now you want to get crystals of it. So what we do is we're going to heat the solution. We already have the solution. If you read the question, heat the solution until it becomes saturated. Saturated solution was first covered in year 9. Year 9 separation techniques as part of crystallization. Some students wrote down crystallization and there will be not enough for that 2 marks because they want you to describe the steps. So saturated is still a solution. So there is no solid at this point. You do not heat to dryness. You heat until it's saturated. This basically means you concentrate the solution by removing as much of the water as possible so that you concentrate it, but you still have a solution. There is no solid at this point at all. So what happened afterward is you must allow the saturated solution to cool. And when you allow this solution to cool, crystals will form. So crystals are solid. Crystals form as a solid. Afterward, you can filter the crystals because you can filter the solid. And then you gotta wash. You wash the crystals with your distilled water. In fact, you should wash it with cold distilled water, although I don't think that makes too much of a difference, but you do need to use distilled water because your tap water contains dissolved ions and that is impurities. You want dry according to the question. You want the dry crystals. So you got to dry these crystals, which you already wash. After you filter it, and you got the dry crystals in between your filter papers. And that's it really for that 2 marks. Preparation of dry crystals there. Question number 2, we have some bottled water there, and this bottled water contains a dissolved gas. Essentially, this is what you call carbonated, or you can call it sprinkling water. So sometimes they call it sprinkling mineral water, sprinkling water. They basically dissolve a gas in it to make it carbonated and fizzy. Now, as they allow this gas to escape through this glass tube, of course, the gas is not allowed to escape that way because you have a rubber cork or rubber stopper there, and then this gas is bubble. So you bubble the gas. You want to bubble the gas from the drink, which it's dissolved in. Bubble the gas into another test tube, and this test tube contain lime water, because we are going to we're going to test for this gas where this solution, the lime water, will turn cloudy when it reacts with the gas. They want the name. They don't want the formula. The gas is going to be called carbon dioxide. The test for carbon dioxide is using lime water, and the result, of course, is lime water turn milky or lime water turn cloudy. It started from a solution where it's a see-through transparent colorless solution, and it turned milky or cloudy solid there. These are some of the particles in the gas. You could clearly see that the black color one is going to be your carbon, and then the white color one is going to be your oxygen. If you know how to count the atoms, you will see there is 1 carbon and 2 oxygen, so it's CO2, carbon dioxide. As stated in structure and bonding, carbon with a 2,4 electronic configuration and oxygen with a 2,6 electronic configuration, because if you look in the periodic table, you know that the group number, this is group IV, at the top of the periodic table, the group number, it tells you how many electrons are there in the outer shell. How many outer shell electrons are there? Okay, so what happened there is that this is 4 electron outer shell, this is 6 electron outer shell. So each carbon want to share 4 out of 4 valence electrons to complete the outer shell, and the oxygen only want to share 2 more electrons to complete the outer shell. So you've got 2 oxygen. So in doing so, the carbon share all 4. So it started with 4 cross, and now you have got 4 more that you have shared. So carbon has got full outer shell with 8 electron outer shell now. Oxygen has 6 valence electrons, 6 outer shell electrons. I only used 2 for covalent bonding. I still have 4 more around the oxygen. This is essentially carbon dioxide. This is dot and cross. This is display formula. Carbon form 1, 2, 3, and 4 covalent bonds. Oxygen form 2 covalent bonds. Because it's group 6, they just need to share 2 electrons to complete the outer shell. Carbon form 4 covalent bond because carbon needed 4 more electrons to share to complete the outer shell. Anyway, this question is asking you the gas is a compound and not an element. So there are 2 components to the answer, and hence the 2 marks there. Why it's a compound, why it's not an element. We know that it's a compound because there are 2 different elements, or you can say there are 2 different atoms or elements. As you can see, 1 black and 1 white. But what makes them a compound? They are chemically combined. So they have already formed bond with each other. They are chemically combined, and this is in a fixed ratio, not just any ratio. That doesn't make sense because there will be a mixture, but this is combined chemically in a fixed ratio. And of course, it's not an element because there are more than 1 type of atoms. So not element, as CO2 has more than 1 type of atoms. So not just more than 1 atom, but more than 1 type of atoms, because I could show something like oxygen. This is 2 atoms, but only 1 type of atoms. So O2 is still element because you only contain one type of atom. It is a diatomic element because, the two atoms are the same. One type of atoms would make it an element still. Even though you contain two atoms, you call it a molecule, but it is still element there. However, this is not element because you have two different type of atoms. They are chemically combined together in a fixed ratio there. Part C, so this student spilled some dilute sulfuric acid. What is the chemical formula for sulfuric acid? There will be H2SO4. There are two more acids that you're supposed to know from this topic. Nitric acid is HNO3. Then you will get the salt. Nitrate salt is going to be NO3 minus. The other acid, of course, is called hydrochloric acid. Hydrochloric acid has the formula HCl, and then you're going to get the chloride salt, which you call Cl minus, and this is nitrate salt. And from sulfuric acid, H2SO4, you are going to get SO42 minus. This is called the sulfate salt. And all of these were from year 9 chemical formulation. Year 9 chemical formulation. Dilute sulfuric acid, this is acid plus metal carbonate. You will get metal salt, but that is not the name. This is not the name. This is a general name. They want you to specify the exact name. So the metal is called sodium. The salt you get from sulfuric acid is called sulfate. Now you can use the old spelling, which is SULPHATE. I'm just using the SULFATE. It's perfectly fine. Carbonate plus acid, you also get carbon dioxide. You also get water. Whichever order you put them in should be alright, as long as you got a metal salt, which you got to put the specific name in, otherwise it's not correct there. Suggest an observation other than using indicator. So you cannot use an indicator here, which will show that enough sodium carbonate have been added. So that would mean no more carbon dioxide is produced because no more reaction. So no more bubbles are observed. If there are still reaction, if there are still any acid remaining, the carbonate will react with the acid and you will get carbon dioxide gas. Carbon dioxide gas will come out as bubbles. If all the acid has been neutralized, no more bubbles are observed since no more reaction because reaction has finished. Last but not least, sodium metal reacts with dilute sulfuric acid. Metal can react with acid to give you metal salt and hydrogen gas. Why you should not? It's not that it's not reactive, it's just that sodium is a very, very reactive metal. You will learn more about these in the metal topic not very long from now. Sodium is a very reactive metal. It reacts very violently, very vigorously, very dangerously. You can use either of these words, very vigorously, very dangerously, or very violently. They all mean the same thing, so it's a safety hazard, so we don't use this sodium metal reacting with dilute sulfuric acid to give us sodium sulfate. Instead, we use something which is less dangerous, sodium carbonate plus sulfuric acid, giving us the salt, the carbon dioxide and water, which are harmless there after all. And that's it really for this overall tutorial. This is work 3 for the acid, base and salt combined science curriculum. Thank you for watching. Don't forget to click the button on the bottom right to subscribe to my channel. Follow me at ptet.chemistry, ptet.chemistry on Instagram, Facebook, Twitter and Telegram to get connected. I'll see you in the next tutorial video. Thank you for watching again.